In this problem, we're going to examine asymmetric information and how it affects health insurance markets. I've copied all this data into Excel to compute a healthy person's expected income and a sickly person's expected income. There are 74,270 sickly people in this economy, 32,210 healthy people. Both earn $50,454. And if either gets sick, the healthcare cost is $18,804. The probability of a sickly person getting sick is 0.689. The probability of a healthy person getting sick is 0.0967. The expected income of a sickly person is C4. C4 is the person's earnings times the probability of not getting sick. 1 minus C6, which is 1 minus 0.689. If the person gets sick, they have to pay to get better. The cost of getting better is $18,804, C5. We have to subtract that from the earnings in C4. And we multiply that by C6, which is the probability of getting sick. And then we do the same for healthy people. If the person does not get sick, the probability of that occurring is 1 minus D6. If they don't get sick, then they just get their earnings. If they get sick, however, which it has a probability of D6, they have to pay to get better, which is in cell D5. And you got to subtract that from the earnings in D4. So I'm going to copy these two things into Cengage now. Now we need to get the expected utility or expected happiness or expected level of satisfaction for both types of health insurance consumers. To get the expected utility, instead of multiplying, say, earnings times the probability of not getting sick, we have to take the square root of earnings first because our utility function is utility equal the square root of earnings. So we first take the square root of earnings and then multiply by the probability of not getting sick. If we get sick, we have to take the square root of the difference in the cost of getting better and our earnings and multiply that by the probability of getting sick. And we do the same for healthy. So over here, the probability of not getting sick is 1 minus the probability of getting sick, 0.0967. We multiply that by the square root of just earnings. On this side over here, we have the square root of earnings minus the cost of getting better times the probability of being sick. I'm going to copy these into Cengage now. This is the expected utility that we just computed in Excel. Replace this with a numerical value, if you will. This is the square root of the earnings less the premium the person will pay given the probability of sickness and the cost of getting better. We have the square root of the right-hand side because that's our utility function. To solve for the premium, you have to square both sides of this equation, which we do down here. And then you just subtract this value from both sides of the equation and add this value to both sides of the equation. And you get the value of the premium down here. So the value of the premium is the earnings minus the square of expected utility. So for the sickly person, the premium is the earnings, which is in C4, minus the square of expected utility, which is in C9. Then we do the same for the healthy person, and we get $2,008.78. I'm going to copy both of these into Cengage now. Which of the following statements is true? Only the individual knows his or her health status. Suppose there is an insurance company that will provide actuarially fair insurance. If the company cannot determine whether a client is healthy or sickly, the expected loss from selling to a particular person is, we're going to compute this in Excel. Since the firm has no idea who you are when you enter their office, they're essentially flipping a coin, which is why this probability here is 0.5 and that probability there is 0.5. C5 is the cost of them covering your recovery from a sickness. C6 is the probability of a sick person getting sick. D6 is the cost to getting the healthy person healthy again. And D5 is the probability of them getting sick. So the firm expects to lose $7,300.87. We're going to copy that into Cengage now. If the insurance company offers an insurance policy costing this amount, the number of healthy people and the number of sickly people who are insured will equal. Because this premium is more than what a healthy person will pay, the healthy person is only willing to pay $2,000 roughly. The sickly person is willing to pay over $13,000. So healthy people will not want to buy insurance. All sickly people will gladly pay that premium. So all 74,270 sickly people will purchase health insurance. Since only sickly people will buy insurance, the company's per policy loss will be equal to what? Since only sickly people are in the pool, the firm's loss is calculated by taking the difference in the premium the insurance company charges and the cost of returning a sickly person to health. We multiply that difference by the probability of the sickly person getting sick. If the sickly person does not get sick, the insurance company just collects a premium. We multiply that by the probability of not getting sick. We get an expected loss of $5,568.80. We delete the negative sign because we're talking about a loss here. Because the company's making a loss on insuring sickly people, no healthy people are insured, and the insurance company decides not to issue insurance policies to sickly people. If the insurance company is able to gather data on potential customers, like age, race, sex, location, BMI, smoking status, etc., and it does not cover pre-existing conditions, and offers policies that appeal to sickly people, high price, low deductible, low copays, and healthy people, low price, high deductible, catastrophic coverage. The choices its customers make reveal who they are. Since the company is able to determine the health status of their clients, the company will sell 2 insurance policies. The cost of the policy to sickly people will be what they are willing to pay, $13,423.11. The cost of the insurance sold to healthy people will be the premium they're willing to pay, $2,008.78. At these premiums, the number of healthy people and the number of sickly people who are insured equal 32,210 and 74,270. The company's expected profit from selling a policy to a healthy person is We're going to calculate that in Excel. D19 is the premium the company charges a healthy person. D5 is the cost of bringing them back to health if they get sick. And D6 is the probability that they get sick. If they don't get sick, the company just collects the premium. The probability of that occurring is the probability that the healthy person does not get sick. So the firm profit on a healthy person's insurance policy is $190.43. If the person gets sick, which has a probability equal to C6.689, the company has to pay for them to get better, which is C5, $18,804, less the premium of $13,423.11. If the sickly person does not get sick, that probability is 1 minus C6, which is 1 minus 0.689. Multiply that by just the premium that was collected, $13,423.11. And the unit profit for insuring a sickly person is $467.16 per policy. If government prohibits the use of statistical discrimination, mandates that insurance companies charge everyone the same premium, and requires insurance companies to cover pre-existing conditions, one policy costing $7,387.15 will be sold. And the number of insured healthy people and insured sickly people will be 0. Now I'm going to check my work and I should get everything correct. And it looks like I got everything correct.